the available post-processing tools in Discovery. Let's first start with the legend, which is located at the right of your Discovery screen. The legend shows us an engineering variable and range of values in our simulation. You can click on the three dots to change the variable to see other results. Other variables will appear if you are running a different physics simulation such as thermal or structure. You can also switch to a different gradient style by clicking on the small legend settings icon and then clicking on the rainbow icon to change from a smooth contour to banded. You can also see the max or min location for the desired variable. You can set the range for your desired value by clicking and dragging the top or bottom side of the legend, or just entering the numbers for your upper limit and lower limit. If you want to reset your legend controls, you can simply click on Reset button in the legend settings shown here. Next, we have our results arc, which houses visual post-processing tools like contours, vectors, streamlines, particle flow, directional fields, and so on. These tools are useful for visualizing and understanding the flow patterns in a simulation. These rendered results are controlled by our legend. Let's first click on vectors. They can be used to visualize more details about flow direction. To turn on the animation, click on the play button icon. To stop the animation, click on the same icon again. Right-clicking or hovering over the vectors icon will show you a submenu. From here, you can set the orientation of the vectors. By default, it is set to curved, but you can deselect it by clicking on it and your vectors will be straight. You can also change the thickness, tail length, and number of vectors using the following slider bars. Additionally, you can also filter the range of values shown by vectors using the slider bar. By default, the filter is set to gradient, which allows you to filter by the change in your variable, but you can also change it to magnitude, which will filter by the value of your variable. Finally, to reset your filter to default, click on the reset icon and let's turn off the vectors by clicking on the vectors icon again. Now let's click on contours icon. Contours are used to visualize the range and rate of change of a variable. Just like vectors, if you hover your mouse or right click, it will show you a submenu for contours. By default, it shows the highest value for all faces. You can change the surface display priority by clicking on this drop-down menu and then selecting outer, inner, highest value or lowest value. You can also change the location from all faces to all bodies by clicking on this drop-down menu next to location. All bodies priority allows you to filter the range of your variable so that you can only see that particular span. Let's turn off contours by clicking on contours icon once again. Next, click on the isosurface icon. Isosurfaces allows us to visualize a specific constant value of a scalar variable. They can be used to visualize properties such as velocity, pressure or temperature in 3D space. In our submenu here, you can set the ISO value by entering any constant value and then hitting enter on the keyboard. You can also do the same with the provided slider bar. Next, we have streamlines. Streamlines can be used to visualize the flow patterns and direction of the flow. In our submenu, we can change the thickness and number of streamlines as well as reverse the direction of the streamlines using this option. At the top, we have some emitter control options. To turn on or off the emitter control, click on the emitter control icon. If you want to reset your emitter location, click on the Reset the emitter location icon. To change the orientation and location of the emitter, click on the blue sphere to open the local coordinate system for the emitter. Then select any of the axes and while selecting, drag it to your desired location. To rotate it, double click on any of these rotational axes to rotate 90 degrees, or simply click and drag your left mouse button on any of these axes. To change the size or shape of the emitter, hover your mouse on the edge of this orange circular emitter. When it turns white, select it by clicking on the edge and drag your mouse to change its shape and size. Next, we have particles. This rendering option shows us massless particles that simply follow the direction of the flow. In our submenu here, you will find a range slider bar that you can use to once again filter the range of your variable. Additionally, we also provide controls for particle size as well as animation speed. Like streamlines, you can also turn on the emitter for particle flow by clicking on the emitter icon at the top. This will give you very similar options to the streamlines emitter that we just reviewed. We have the directional field. It is a 2D surface that displays the direction of the flow via streamlines. To change the orientation of the directional field, click on the blue sphere again. From this local coordinate system, you can orient or move it to any desired position, like the way we did for the streamlines. In Discovery, these tools can be used individually or in combination to provide a comprehensive understanding of the flow patterns, and it really gives us extra flexibility when it comes to post-processing in Discovery. Apart from all the visual post-processing tools, we have monitors to give you results in discrete numerical values. Monitors can be exposed by clicking this icon here. These default monitors are coupled to the physics you are solving. Since we are performing a fluid flow simulation, Discovery automatically created maximum velocity and pressure drop as default monitors. Additional default monitors will show if you are solving additional physics types. You can also create your own monitors for many desired variables and locations such as planes, surfaces, points, pieces, and bodies. To create new monitors, go to the Simulation tab in the top ribbon and then click on Monitors under the Results section. From the left side of the heads-up display or HUD, choose any desired variable. Here we are going to create some mass flow monitors for front vents and the rear vents. So let's select mass flow here and then select the outlet faces for the front top vents and click on green check mark or just hit enter on your keyboard to create it. The moment you do so, a new plot is going to pop up on your screen for the same monitor. Let's close this one now and rename it as mass flow upper front. Let's do the same for the rest of the outlets. In total, we created 4 mass flow monitors, 2 for the front, top and bottom outlets and 2 for the rear, top and bottom outlets. These monitors will populate based on subsequent simulations. To simplify your experience in Discovery, we have incorporated a Save Current Scenes feature. This allows you to save multiple post-processing configurations where you can easily switch between them. Discovery will record the geometry orientation and variable being rendered within the saved scene. Let's save some scenes using vectors first. Then let's proceed to save scene with directional fields focused on the rear vents outlet. Finally, let's save one last scene with streamlines emphasizing on the outlet. This functionality enables seamless switching between scenes based on your selection and orientation. It proves particularly useful when exploring design variations and assessing their impact on the overall results in the area of interest. Now that we have created monitors and saved scenes, let's create a report with this information. To generate a report, go to the top left corner and click on the File menu. Then click the Create Report option. Discovery will automatically generate and open a comprehensive report file in .html format or Word doc format. It includes a summary, a 3D model that you can rotate and zoom in and zoom out, geometry components, materials data, physics conditions, saved scenes, and monitor values. If we select the vector scene that we saved in our last video, we can see that the top region of outlet vents at the rear of the car is pushing more air compared to the lower region. There is almost no flow and some reversed flow occurring in the lower region on the rear side. To fix this, we can channel more air to the lower vents if we can create a guiding vane to redirect the flow. Let's cross-check the same scenario with our streamlines and try to find out what we can identify from there. Let's go to our streamlines saved scene. Here with the streamlines, we have much more flexibility because we can move our emitter location to any location in the geometry to see the flow pattern in a certain section. Let's click on this blue blob and while selecting it, snap it to one of the outlets at the top rear vents. Let's select the Z direction from this local coordinate and move it in the Z direction or blue arrow direction so that we can see flow coming through both the vents. From here we can also see that most of the flow is going through the upper vents and there is little to no flow near the bottom vents.